Hello. Okay, what are we going to do now? We are going to look at an example, a chemistry example, a question where we have to use the limiting reagent concept to find out the amount of product that is going to be formed. Okay, let me show you what this question is all about. All right, now this is a reaction where hydrogen reacting with oxygen uh, to the molar ratio 2 to 1. 2 moles of hydrogen reacts with 1 mole of oxygen to produce 2 moles of water. Okay, now they are asking us to find the number of moles of the water that is going to be produced when you have 5 moles of hydrogen and 8 moles of oxygen. Now, the first question you need to ask yourself is this: how do we know that this question, in order to find out the number of moles of, in this question, in order to find out the number of moles of water, you need to use the concept of limiting reagent. That's the first question you need to ask yourself. Yeah. Okay. The most easiest way to work that out is see that you've been given the number of moles of both the reactants. You have been given the number of moles of the both reactants. In a normal stoichiometric question, you are going to be given only the number of moles of one reactant, and they suggest you to assume the other reactant is in excess. Okay. Now in year 11, all the questions we did in terms of stoichiometry, that is the assumption we had. You were given the number of moles of you had been given the number of moles of one reactant. You had to assume the other reactant is in excess. In this case, it's not the case. As you can see, you've been given the number of moles of hydrogen as well as the oxygen. Now, this is where you need to find out what the limiting is. That's the first step. What the limiting is. Once you know what the limiting is, what do you need to do? You use the number of moles of limiting to find out the number of moles of the water. In this case, that is our unknown. Okay. Now, these are the steps. Firstly, find out what the limiting is. Then use the number of moles of limiting to find out the number of moles of the unknown. In this case, our unknown is the number of moles of water. All right, step number 1. Now let's look at those steps. Step number 1. What is the step number 1? Find the limiting reagent. That is the step number 1. Find the limiting reagent. Write that down. Find the limiting reagent. To find the limiting reagent and the number of moles of limiting, not just finding is going to helpful. You have to use the number of moles of the limiting. Okay. To find the number of moles of limiting, what do you need to do? Remember the steps. Get the number of moles of one reactant, which is hydrogen, which is what? Which is going to be which is equal to 5. Then that's the one that is given to you, and divided by 2. Then what's that number? 2.5. Okay, 2.5 moles. So we are just trying to find out the limiting. Step number 1. Then get the other reactant, number of moles of oxygen. Okay, which is 8. Then what's its coefficient? Remember, coefficient is 1, right? 8 8 moles. So out of these two numbers, which one is the smaller number? Which one is the smaller number? Hydrogen is the smaller number, so that our limiting is the hydrogen. You put a circle around it because you just identify the limiting. As soon as you identify what the limiting is, put a circle around it. Okay. After that, always refer back to the original number of moles of the limiting, because this 2.5 is not the actual number of moles of hydrogen we got. We did this calculation, or we divided given number of moles by 2, which was the coefficient, just to find out the limiting, what the limiting is. Right? After you have found out what the limiting is, make sure you do not use these numbers, because they are not going to be part of our calculation. You just do this step to find out what the limiting is. then you go back to the original number of moles of limiting, because that is the one that we are going to use in our calculation. Right, is that clear? So we found out what the limiting is, then write a statement. Therefore, hydrogen is the limiting reactant. Make that statement, right? Reactant. So do that statement. So step number 1 is done. Now what do? We are going to use the number of moles of limiting to find out the number of moles of water. Now it's very clear, it's a 1-to-1 is the ratio, so 5-to-5 is 5 moles. But we'll write it properly. So let's write it properly. What I'm trying to say is this. So let's put unknown over known. What is our unknown? Water, NH2O. Okay, what is our known? Your known is always going to be limiting. Known is always going to be limiting. In this case, limiting. And in this case, hydrogen. Always that's the limiting, right? Limiting, okay. The ratio is 1-to-1. Therefore, number of moles of hydrogen, so the number of moles of water that is going to be formed is equal to the number of moles of hydrogen, in which is our limiting. So number of moles of hydrogen is 5, because we worked that out. That's the limiting number of moles. No, not the 2.5. Go to the original. Because this is just a step. This is just a step we do. A small step, intermediate step we do just to find out what the limiting is. So in this case, number of moles of hydrogen, which is 5.0 moles. Therefore, number of moles of water that is going to be produced is 5.0. Now there could be another question asking you, okay, now we know that the limiting is the hydrogen, so excess is the oxygen. They can ask you, what is the amount of oxygen? In other words, what is the number of moles of the excess reagent that is going to be left over? Number of moles of excess reagent that is going to be left over. So in order to do that question, so okay, let me write that question. What is the, if there was a question like that, what is the amount of the excess reagent, amount in moles, okay, left over after the reaction. So how do you do that question? So they are pretty much asking you, hey, how much of the excess will be left over after the reaction? So to do that, what do you need to do? Again, you use your limiting to find out the number of moles of hydrogen used. Number of moles of hydrogen used. So what do you need to do? Here we are going to say, what are we going to do? We are going to find out the number of moles of hydrogen used. If you know the number of moles of hydrogen used, you can find out the number of moles of hydrogen that will be left over. So to find out the number of moles of hydrogen used, that is your unknown, that is used, okay, over your known. Who is your known? Oh, your limiting. Limiting is your known, which is number of, I made a mistake. Stupid. Not the hydrogen. That's the number of stupid. Our excess is oxygen. Oxygen, not the hydrogen. So I had to do this. Sorry about this. Number of moles of oxygen used. My mistake. No mistake. So this is your unknown, because we need to find out what is going to be left over. Number of moles of oxygen. That's our excess. So we try to find out how much of oxygen will be left over. If I said hydrogen, sorry. Then that's the number of moles. In order to do that, you need to find the number of moles of oxygen used. That is our unknown. Your known is going to be the number of moles of hydrogen, which is our limiting. Ratio is 1 to 2, right? 1 to 2, 1 to 2, 1 to 2. Then what do? Therefore, number of moles of the oxygen used is going to be equal to what? You look at the ratios. Huh? Number of moles of the hydrogen, which is your limiting, divided by 2. You rearrange this, okay? I hope that that's not going to be difficult. So in this case, we can work that out. Number of moles of hydrogen is our limiting, which is original is 5. 5 over 2 is 2.5. So we are going to use 2.5 moles of oxygen. Therefore, number of moles of oxygen left over or in excess. How do you do that? In order to do that, originally we had 8 moles minus 2.5, which is going to be equal to 5.5 moles oxygen left over. All right. Now we will do another question similar to that, so that will give you a good practice. Okay. That's it. Love you for loving chemistry. See you soon. Bye.